Hello everyone, I hope you guys are doing well. I am here with chapter number 10, which luckily is a short and easy chapter. Most of this chapter you have probably seen elsewhere in school or college, depending on where you went to school or college, but I am going to put together the three main concepts that we have in this chapter. One is called the high-low method. Second is a brief discussion of regression analysis if you have not seen it before in any other course. And the only new portion in this chapter which you have not seen before is probably learning curves. So all these three are cost estimation techniques, and we are going to go into the details of cost behavior and cost estimation quickly. Okay, so here we go. So first thing we are going to do is to refresh your memory with the definition of fixed costs and variable costs. Remember, fixed costs are constant regardless of the volume of activity. It does not change with number of labor hours or number of units produced, etc., etc. Examples are like rent, salaries, insurance, etc. Variable costs, on the other hand, are those that fluctuate. Okay, they are higher when you make more units, etc., etc. Typical examples: material, labor, sales commission, etc. Okay. Now, there are some costs which are neither purely fixed nor purely variable. Okay, these type of costs are called mixed costs. Okay, in real life, you have lots of examples of mixed costs. For example, your phone bill is an example of a mixed cost. They charge you something monthly, and then if you use more minutes, then they would probably charge you something per unit. So typically the definition of mixed cost, okay, is described by what we call the equation of a line. Okay, you might have seen y equal to a plus bx or y equal to mx plus c in school or college or in another course somewhere. So basically that is what the cost look like. Typically, you would say, if I draw a picture, that the line begins from here, which is the fixed portion of your cost, and then it kind of goes like this. And if you want to figure out what is the slope of this line, then you take any 2 points, x1 and x2, and then y1 and y2, and you kind of try to measure the change in x, which is what we call del x, and then we call del y, and then we divide to figure out the slope. We are going to get into that very quickly. Okay. Cost analysis, more importantly, cost prediction, okay, is important to companies because they are doing budgeting, they are doing what is likely to be my future profit, etc., etc. So a very useful concept in real life. Okay, first thing we do is to work with a high low example. High and low are basically two data points that we pick out of a whole bunch of, suppose I have some data which is given to me like this. Okay, so I say this is my lowest point and this is my highest point, and I'm going to try to make a straight line between them. That's what we mean by high-low. Given a whole bunch of data, picking the lowest and the highest point and trying to fit a line, straight line, okay, is basically what we do. The example is saying you are given a highest activity. You didn't have to pick, they are already giving you highest and lowest activity, and they are giving you your cost. Okay, remember the number of units produced is your independent variable, which is what we call x. Okay, resulting cost is your dependent variable, which is what we call y. Okay, so you are given two data points, x1 and x2, and y1 and y2. Now question is asking you to write the cost equation. Okay, I'm sure you have done it many times before, but let us just refresh your memory and go through the steps. So here we go. Okay, the second question is saying, can you write the equation so that we can estimate future costs? I'll show you an example of that too. Okay, so here is the first thing. You take the change in cost, which is your change in y, okay, which is what we have taken here. These are the two costs that I'm given. So I take the change in y and I divide it by the change in x. This is my change in x. Okay. So as a result, I come up with variable cost of $4 per unit, which is what we call the B, or the slope of my curve. Okay. Now I'm ready to figure out what the fixed cost must be. I can take either of these two data points, either this one or this one. Okay. And I can figure out what the fixed cost must have been. I am going to take, okay, the higher point here. I am saying my 52,000. So remember, if I say my equation is y equal to a plus bx, okay, for this point, I'm saying when my cost is 52,000, I don't know what my a is, but my b is 4, okay, and my x is 10,000, right? So clearly my a is 52,000 minus 40,000 of my bx component. That gives me $12,000 of fixed cost. Everybody with me? Okay. Now I'm ready to write the cost equation. This is what my equation would look like. Your y, which is your dependent variable, is your total cost. A, which is your alpha, or the height of the line. We also call it fixed cost in our context. Okay. B is the slope or the variable cost for us. And x is the independent variable or the activity level. Once you have that, okay, you can do part 2, which is, can you use the equation to estimate future cost? Suppose the question tells you that next month or next year, my activity is likely to be 8,000 units. What is likely to be my cost? So all you do is to take this equation that you have, okay, put x equal to 8,000, which is what we did here. And then you can predict the cost. So estimating cost is useful because it gives us the power to predict costs. Okay, so this is the simplest version of cost prediction using the high-low method. Okay, now let us try to look at the pros and cons of high-low. Okay, first of all, it is a quantitative method which is going to separate the fixed costs and variable costs so that you can do a very easy and quick estimation and prediction. Okay, what are the weaknesses? Okay, weaknesses are that it basically ignores all other data. So again, look at the example of a weakness. Suppose I have this as my high, sorry, low, and this as my high, and suppose my rest of my data is all here. Okay, but my high-low method is going to give me a line like this. Whereas the data that I have is actually dictating that I should make a line like this one. So these two could very well be outliers, okay, or unusual observations as we are calling it. So all the information being thrown away and only 2 points used to make the entire prediction is the main weakness of this method. Okay. However, people use high-low heavily because people use this as a ballpark. For example, if you say, I'm looking at data like this, very tightly put together data. Okay, if you make a picture and then you say, okay, I'm going to use high-low by this, and you put a line like this, then you know that your data is so nicely well behaved that you can use regression, you can use any other sophisticated technique. It's not going to make a big difference to the quality of your estimate. So why not do something simple? Sometimes people do that. Okay, so it may overlook data patterns, which is something that we discussed. It can distort your cost estimation. So a limited method, simple but not very reliable in all situations. Okay, let us go to the second part of our cost estimation technique, which is called regression. Some of you might have heard of regression before. If you haven't, then we should define it. Okay, regression is basically the same thing, except that it is going to use all data points, every single data point, even if you have 10 million of them. Okay, the idea is to still fit an equation of the line like y equal to a plus bx. Okay, so it is still going to have the intercept, which is your fixed cost, okay, which we call a, and variable cost, which is b times x. Okay, so the basic idea is exactly the same as high-low. Okay, so the good news about regression is that in this course, we are not going to ask you to calculate regression, although regression can very easily be done on your calculators or computers these days. So we are not going to ask you to do it. We are just going to ask you to interpret a regression result. Okay. So some of the things that you look at when you look at a regression result is called R squared, which is basically the correlation between X and Y. We talk about residual or standard error, which is the difference between your estimate and your actual numbers. And significance test is basically a robustness test. We call it t-test also. All these things are trying to tell you how reliable and how robust your regression is. So we are going to kind of look at that. Okay. Regression is a very, very widely used method of estimation. In fact, the entire accounting research, okay, is largely based on running a regression of a company's earnings on the likely stock price. So the what we call earnings return relation is one of the most popular regression in the world. Okay. Obviously, like all other quantitative methods, it can be limited because a lot of times it is simply showing you correlation. That does not mean that if X and Y are moving together, then X is causing Y, X and Y both be caused by, let's say, Z. Okay, so these are some of the cautions that we have to worry about here. Okay, so suppose I want to show you one small little. Suppose you are given that using a regression method, you are given a cost of 14,000 plus 3.8x. Okay, so you understand that this is your fixed cost portion, this is your slope or your B or your variable cost per unit. Okay, so if the question says, suppose the level of activity is supposed to be 9,000. Okay, using this regression equation, how would you estimate the cost? Well, you'll say 14,000 plus 3.8 and you will plug in 9,000 here. Okay, and it will give you 48,200. Okay, because this equation has been developed using every single data point that I had available, it is considered to be a little bit more reliable than high-low method. Okay, let us go to the third and the only new portion of this chapter, which is called learning curves. What is the concept of learning curves? Learning curves are essentially saying that because you have three costs, remember manufacturing costs are made up of three things: direct material, direct labor, and manufacturing overhead. Direct labor here involves human beings. And human beings have brains, and brains learn, which means no matter whatever is the time taken by a human being to make one unit when he's making it for the first time, is going to definitely go down over time because he becomes an expert. Okay, so labor efficiency improves, and therefore the labor cost over time cannot be linear, and therefore we are almost compelled to drop the linearity assumption, which is what we made in high-low as well as regression. So we are trying to go towards a non-linear method of cost estimation with the help of learning curves. Okay. So there are two main approaches to learning curves. One is called cumulative average learning curve. This school of thought believes that people learn over time slowly on an average. Incremental learning curve, on the other hand, believes that people are learning very sharply, which means every time they make a second unit, the time taken has reduced by a certain percentage from the first unit. Okay. They both assume labor efficiency improves, but their rate of efficiency assumptions are different. I'm going to show you an example. Okay. So for example, if you are given an 80% learning curve, okay, what does that mean? It says if you made the first unit and it took 10 hours to make, okay, then under the 80% learning curve, the time taken has come down to 80% of the previous one, which means the second unit will take 8 hours. Okay, this is what the incremental method believes. The average method, on the other hand, let me erase this and show it to you. Average method says, suppose these are your units, unit 1 and unit 2. Time taken is 10 hours. Okay, let's make another time column which is called total time, and a third column which is called average time. And 80% learning curve has to be here in the average column, not in the total column. So if first unit took 10 hours, total time is also 10. Average time is also 10 because 10 divided by 1 is going to give me 10. Okay. Now it is saying that the average time is 80%, which means 8 hours. Okay, the average is here. Okay, so if the average is 8, which means total time was 18 hours. No, 16, sorry. 16 divided by 2 is what is giving me 8 hours. Okay, what does that mean? I can go and do backward induction and say the second unit must have taken 6 hours. Okay, so the 80% learning curve applies in the average column for the cumulative average time method, whereas you can see if we were doing incremental method with the same data, this would have given me a 60% learning curve. So the learning curve is kind of flatter in my average time model is basically what I want to show you. Okay, we'll take a numerical example soon. Okay, so once again, it's a very important concept because people can estimate what your future costs are going to be depending on what is going to be the reduction in your labor costs, how many people you should hire, etc., etc. The more experienced the people are, the lesser the amount of labor force or number of hours you would require are some of the very practical uses of learning curves. Okay. What are their limitations? Some people learn sharper are sharper than others, so some people learn faster. So the theory may not apply to almost everybody who believes who works for the company. Some people might work faster or slower than others, so it can probably affect your estimations. Okay, here is an example. Okay, suppose we talk about an aerospace company, okay, which are making custom aircrafts. Okay, it takes 100 hours, okay, to make the first unit, and you are also given already that the learning curve is 80%. Okay, so as I explained to you on the previous slide, learning curve cumulative means each time the production doubles, the average time, not the total time, falls to 80% of the previous average. Okay, so let us look at some data here. Okay, we are saying number of units 1, 2, 4, and 8. Okay, this is the other thing that you have to concentrate. Each time production doubles. Okay, since it is a theory almost like any other theory, the epsilon theory, the geometric series theory. Okay, someone has made this theory and the theory applies only when the number of units double. So when we go from 1 to 2, 2 to 4, 4 to 8, what happens? Okay, average time is first unit 100 hours, second unit 80% of that on an average, fourth 80% of that, eighth 80% of that. Okay, notice two things. One is that the theory is completely silent on what happens to the third unit, what happens to the fifth, sixth, and seventh unit. It only tells you that as the number of units double, okay, the time taken comes down to 80% of the previous average. Okay. Second thing to worry about is what are the total hours taken. Okay, now this one is, as I said, 100 times 1. This is 80 times 2 equal to total time times 4 and times 8. Because how do you calculate the average of anything? You say total divided by number of units, right? So if your total is, let's say, 256 and number of units are 4, then average is going to be 64. Okay, so the number has kind of come from here in terms of average, but you have to be careful when you are doing cumulative average because it is an average method. Okay, this is how the numbers change. Okay, so the interpretation is saying average time drops from 100 to 80 and then 80 to 64. Okay, the popular question will say, suppose I pay $30 to my labor. Okay, then 409 times 30, okay, is going to be my expected labor cost for the 8 units. Why? 8 units took 409 hours. How did I come up with 409? I said 51.2 multiplied by 8 because this is the average time taken by the 8th unit, right? All 8 units took 51.2 times 8, okay? And how much did I pay to them? I paid the number of hours taken multiplied by 30, okay? So now let us compare and contrast it with the incremental, which is a much easier one, okay? The 80% factor given to us in the question is also going to apply to the incremental units, almost like the concept of average cost and marginal cost in economics. Average cost is like your cumulative average method, and marginal cost is almost like your incremental method. Okay, and this is what your incremental table would look like. Notice you need only one. From 100, it comes down to 80, which is 80% of that. It comes down to 80% of that, comes down to 80% of that. Both leave gap in the data because all they are trying to do is to tell us what happens when the number of units double. So either the question will never ask you for 5, 6, 7, or 3 units for that matter, or they will give you an imaginary number. Okay, there is a method. We can use that. We'll talk about that in the class when we use a, okay, x to the power of b. We can use a non-linear equation and then we can kind of look at what is the x to the power of b, etc., etc. But we will talk about that detail since we are going to ask you to use a simple calculator in the exams. Okay, you'll not be able to do the power function, etc., etc. Okay, or the value of b in a nonlinear function is also a log function. You won't be able to use log in the exam also. So we are going to keep learning theory to be very, very simple, something that you can do with the help of a table like this one and never have to use the equation. Although I'll show you the equation in the class, but basically this is what you are going to need for the purpose of your exams. Okay, so this is all we have for you. All right. Okay, have a great day. I will see you soon.